Hello, thanks for joining us for our last day of the Pass the Salt. Our third conference today will be given about a tool which perform remote forensic investigation. It's a tool based on the live CD, and the speaker will be Xavier Martens. Xavier, you may start if you want.
Okay, thank you for the quick introduction. Let me share my screen. Okay, can you see the screen?
Yep.
Yeah, oops, so now let's check if everything's okay. You see this? You see this?
Perfect.
Okay, perfect. So welcome everybody. First talk of the last day. Good afternoon, good morning, good evening, depending on the location where you are watching us. So what I will present you today is a specific live CD to perform remote forensics investigations, especially in the context of the COVID-19, because yeah, probably most of the attendees are stuck at home working remotely for a few months now, but the business must go on. You have to continue to provide services to your customers. So it could be interesting to have nice remote tool to continue to provide your best services to your customers. So a few words about myself. So my name is Xavier, also known as XMe on Twitter. I'm quite proud of to be a speaker for the third time at Pass the Salt. So thank you guys for accepting my talks every year. So it means that I hope that it's interesting for you. Otherwise, I'm a freelance based in Belgium. I consider myself more as a blue teamer. So it means that I'm doing more and more defensive security, and I try to protect my customers and their data and their assets. I'm also a SANS Internet Storm Center handler, and I'm a co-organizer of the BruCon Security Conference. The talk today will be quite short, so I don't have a lot of time to present you all the features around the tool. So I will answer the question at the end of the presentation, but also if you have more questions, if you like to chat, we can continue to have discussions. So just follow me on Twitter and I will be happy to help you and to continue to provide you information about the tool. So yeah, we all know that 2020, if we could do a Control Z or undo for this year, it would be perfect because it's really a shitty year, right? I think. So 2030 change the behavior, all the behavior, how we work, how we have contact with the people. But of course, we are working in a nice field, so in info security, because we are able to work from almost anywhere. I'm working from anywhere. I'm working from home, from any location when I'm at my parents, on the road, and so on. But of course, we need to have more and more tools to provide such kind of services. So my idea beyond this was it's a good opportunity to present you the tool today to perform so more and more investigation remotely and safely. I'm pretty sure that everybody faced this situation. So if you are involved in incident handling, forensic investigation, it's always like this. Friday 10 p.m. You are relaxed at home with your family, watching a movie or having good times with friends, and suddenly the phone rings because you are on duty. It happens from time to time, and you have a customer who calls you and say, "Oh, you need to come as soon as possible to investigate the incident because we have suspicious about a user, about a system." And of course, the customer is located far away from you. You don't have time to drive, or like we do today, we cannot travel easily, especially if it's outside Europe. Um, it's occur always like this, and many incidents, to not say all incidents, occur always at the wrong time. I don't know if you remember WannaCry. So you see on the right of my slide the nice screenshot when it appeared for the first time. It was in May 12th in 2017. And I remember this day because I was on duty for the Internet Storm Center. And when it really started to infect more and more networks, basically it was Friday PM. So we had very good times because we were investigating stuff. We received information from everywhere. So basically, it's always happened at the worst moment. So you must be ready to deploy tools and to not lose time by traveling, taking your car, booking a plane, stuff like this. Not waste my mouse like this. So a few words about forensic. The goal of this presentation is not to explain you how to do forensic investigation. It's totally not the goal. The goal is to present you a tool which is based on many forensic tools that could be deployed in a few minutes to investigate an incident. But it's not, my goal is not to explain you how to do the investigations. But basically, forensic investigation, they are based on the collection of relevant data on the compromised system, and very important, in a safe way. By safe way, I mean that you cannot change of course, the data. You must be sure that you don't alter the evidences, and you need to collect artifacts, which are basic ones: file systems, files, directories, a memory dump, access to the registry if it's a Windows system, but also useful artifacts coming from third-party applications. So not directly based on the OS, but you can have, for example, the browsing history is very interesting, because the victim you may find which website have been visited by the victim just before the infection and so on. So basically, the forensic is just collecting all this kind of information to be able to guess what happened and to take actions to remediate the incident. To do this, of course, we need some tools. So you need a toolbox. Every forensicator has a different toolbox. So you have very good tools, very known tools, renowned tools, but everybody has its small bunch of scripts, Python, Perl script on specific utilities that it uses, and you can find plenty of them. Some of them are based on agent. So it means that you already have a small agent running on the computer, on the endpoint, and this agent is very interesting because it helps you to automatically collect information from the system, even if it's located far away on the other side of the world, a few thousand kilometers. Some of them are the well-known NKs, which is very expensive, but works quite well. Google Rapid Response, Mozilla Investigator, OS Query, OSSEC, and so on and so on. So use your preferred one. But you can also have on-demand tools like the SIFT workstation developed by Sense, which is also a live CD. And this live CD has a bunch of tools already installed, and the workstation helps you to do the basic forensic steps during the incident management. It's a nice live CD, but the main issue with SIFT is that it's a live CD and you have to boot your SIFT workstation to take the evidences, but you also need to be on site to use different tools, or you need to have skilled customers, skilled user, and ask them, please do that, do this action, this one, this one, this one. And everybody knows that it's not the best situation when you are facing a big incident, because people are quite stressed, they are overloaded by other tasks, so they don't have time, they don't have the skill or the skills to do that. So SIFT is a nice tool, but for me, the biggest issue is that you cannot prepare it and to use it from a remote location very easily. So the requirements, based on my experience, for me, we need something which is easy and quick to deploy. Of course, if a customer calls you, you don't have time to spend 2 days to prepare your toolbox. The tool must be available, be online, to be downloaded by the customer and deployed in a few minutes, let's say maximum a few hours. It must be forensically aware. So forensically aware, keep in mind that, again, it must be able to take the evidences in a safe way to not break to not alter the evidences. It must have your toolbox pre-installed. As I said, your toolbox is your own toolbox. It must be able to do disk management, so disk manage disk, but also mount file system for multiple operating systems. Just think about NTFS, X4, X3, all kind of the macOS file system and so on. You have also interaction with user, which is quite interesting. What does it mean? Customers, they like to be in contact with you during investigation, and if you can share in almost real-time information with them, it's always a good point. It must be compatible with many networking systems. The customer must be able to keep control. It's very important, because if the customer has the feeling that it's because it's his own system, so the customer must remain in control, and must, if you give the customer the opportunity to control his own system even during investigation, it's a good point for you. And of course, a low bandwidth usage. So all the data must be processed remotely, and you just collect and you just grab locally only the result of the investigation. So for example, today we have laptops with minimum 16, 32 gigs of memory. If you need to take a memory image and then to download this memory image locally, it will take a huge amount of time, which is always a bad point when you need to investigate as soon as possible. So let's talk about the tool. So the tool is called BitScout. It's a customizable live OS constructor based on Bash, which is nice because first, it's a live Linux OS. It's based on Ubuntu. It's very simple. You can customize it at build time. You can extend it at runtime, very important. So what does it mean? If you don't have a tool, if you don't have a script installed by default on Live CD, you can always install it while you are doing your investigations. It has a minimal system requirements. It uses low bandwidth and of course a VPN to encrypt all the data between you and the customer. It has unprivileged isolated access. We will come back to this in a few minutes, and is based on two roles, the expert and the owner. The expert is you, the forensic guy, and the owner is basically the customer. So the key points for BitScout, you have some kind of different layer like the OSI model. So on your right, you see that you are starting from bottom to top. You have the live CD, then you have the overlay file system, you have a bind file system, you have the root file system, which is basically a container because all your environment runs in a container. Then you have evidences. You take snapshots because you have QEMU installed on the live CD, and then you can also execute and boot the system virtually through the live CD to take evidence. So you have multiple layers like this. And the key point, so the first one, the expert, is root only in his restricted environment. So when the live CD is booted, when I connect to the live CD, I'm connected in my own Docker. I don't own the system. I have only access to the file system and to the system that the customer provides to me, nothing else. So it means that I will not be able to scan, to connect, and to grab information from the complete network. It has multiple layers, like we saw, you see on the right. It accesses only authorized resources, and also it prevents the tampering of evidence. So the architecture is quite simple. You are the expert on the top, and you are connected through, so for example, via a laptop, my MacBook, at home, at work, at another customer premises. And the owner boots the live CD on the system. The system can be booted on a physical system using a real live CD, a USB stick, but you can also boot it on a virtual system. So you just deploy the ISO file in your data store for OS6, for example, and you boot a virtual system in a complete environment. And once the system is booted, the owner, as you see on a small screenshot, it has this kind of very easy console where you can do specific basic tasks. We will talk about this in a few minutes. And what's important, automatically when the live CD has booted, it will just open the VPN connection back to the expert, and the expert will be able to SSH to the Docker and to start investigations. Plus point, the owner and the expert can always chat using an internal IRC system, so we can discuss and we can always exchange information. Oh, please give me this password. Please give me, could you tell me where is located this file, blah, 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 and stuff like this. So you are always in contact with your customer. A very good point is the configuration and customization. So you cannot download BitScout like this, and you cannot execute it like this. You have to prepare your personal ISO file. So for example, for my company, my business, I have my own personal ISO file. Why? Because first it connects to a VPN. So you need to prepare the VPN configuration because it goes back to my own VPN server. You need to set up SSH keys. You need to set up the IRC, which kind of channel you would like to have and to open to discuss with your customer. So a very important point, The expert, so you, the forensicator, you need to deploy some server and you need to have an infrastructure. You need a VPN server, you need an IRC server, you need a syslog server, and many more if you deploy extra tools. So you need to prepare your environment. The customization is very easy because as it's displayed on the presentation of BitsCode, it's based on Bash script, very easy. So you don't have to be a high-skilled developer. If you can write simple Bash script, you can install your own tools. So basically, you see on the screenshot that you have different scripts depending on the installation steps. For example, you have change root, install forensics, install custom, install kernel, install remote access, and so on. And once you created all your scripts, so you can add your own script as you want, you just have an automake.sh script to build the ISO image, and the ISO image is available for your customers. Of course, you have to test it several times to be sure that it's stable, it works, that the VPN keys, the SSH keys are properly installed. But once it's done, your ISO file is ready. So the ISO file is available on my company web server, and any customer is free to download it immediately when he requires. He asks me to do some investigations. When you boot it, how to boot it? So you can boot, you can burn a CD. That's the hold session hold method. You can generate USB stick, or you can just add the ISO file to your data store or to your place when you have your virtual environment. And you can just, in this case, you can create a temporary VM and you assign the suspicious VMDK to this VM, or you can just boot the compromised VM using the CD, the ISO file. And of course, it's very important for your customer, the live CD needs some internet access, at least DNS resolution and UDP 1194 for the VPN to be able to call back my VPNs or your VPN server. So very easy to deploy. And I have a quick documentation for my customers. So they just have a documentation, PDF file, how to do this. They install the ISO file, they boot it, and I'm just monitoring the callback. And when I see the VPN is up, I can automatically start the investigation. Of course, BitsCode, so your live CD will be deployed in a specific environment, and you don't know the environment. So it means that it must be very, very configurable regarding the network. And the network setup, you can work. By default, it will try to fetch an IP address through the HTTP, but you can specify a static IP address. So the customer is able to specify the static IP. It can configure proxy, a SOCKS proxy. It can also serve for SSIDs and connect to Wi-Fi settings. Could be a WPA, WEP, whatever you want. So basically, it can connect on any network. Remember that the goal is to open a VPN back to the expert system, and then the expert, it does just a SSH using a specific SSH key, which is installed on the live CD, the public key, and it will have access to the BitsCode system. It was a quick introduction, very quick one. Now I will present you some demos, and you will see in real time, because I did not have recording. I will do everything live, some demos to prove you and to show you how it works. So the first demo is just the network setup and remote access. So I will show you this live. Well, yeah, let's switch like this. So this Ubuntu system, considering that it's the expert system, I will just do a ping to my to the IP address of the live CD, which is bitscode.vpn.functional.de, and you see that the system is not live. I will just boot my VM. So it's a classic live CD. So you just keep it boot and do all the setup. So the lab is designed, this virtual machine, this one, has a VMDK attached to it, and the VMDK is a Windows 7 operating system, a Windows 7 host. So I will be able to make you some demos. And so it's booted. You see immediately that my VPN is up. So now I can SSH to the system. User at BitsCode. Here we go. I'm on the system. So in this case, the customer had nothing to do because by default, the live CD grabs an IP address via DHCP. He got a default gateway, DNS servers, and he's able to find his VPN server and to call to phone call. But you see that for the customer, so this is the customer system, this one, the blue screen. It's very easy. You see, you have a quick introduction, network configuration, disk status, supervised chat. We will come back to these different options later, but it's very convenient. So network, you can just enable host control. You can put a static IP, syslog, Wi-Fi settings. Very easy for the user because it's just a simple menu. And if you go to status, the customer is able to see your messages, the different routes, what is the VPN up and running, and so on and so on and so on. Very, very convenient. Don't want to shell. I don't know this. Okay. So now my system is up. Let's go back to the slides. This is the first demo. So you see that in a few seconds, so the customer downloaded the ISO file, booted the ISO file, and you have access to a remote system. Again, when you are on this system, you are in a container and I don't have access to the customer network. So I cannot start any ping, I cannot surf using this proxy, I cannot mount SMB shares and so on. By default, of course, it can do it. So if it gives you access to mount a SMB share, to create temporary files, to dump some stuff, it's available. But by default, you are really in a restricted environment. So what about disk management, which is the key point? By default, the live CD will have VMD case attached or will have a physical disk. Let's see, for example, it's /dev/SDA. And the goal is to create mappings to be able to work on evidence file system. So you will never work directly on the physical or the real file system. You will work on evidence file system. And to do this, the customer must create some mappings. So how does it work? I will go to the disk menu, and by default, you can see what's attached to the live CD. So as I said, I attach a Windows system host. So I have a /dev/SDA available, and you see the two commands partitions, the first one and the second one, which is the real operating system. So SDA1, SDA2, which are NTFS. And it's up to the customer to give you access to the file system which are necessary to do the investigation. So it keeps the control. It's very important. You will not have access to /dev/SDA. And to do this, the customer must map some drive and make them available for you. So to do a map, you can map the complete disk, but you can also map a specific file system, a specific partition. So let's map SDA2. And then you select if you want to map on a read-only file system or read-write file system. Of course, you select read-only because you don't want to break evidences, so you map it to evidence. And now you have mapped SDA2 to evidence. So now, if we do a view, the customer is able to see the status. So you see the physical drives, and now we have existing mappings. We have one, SDA2, which is mapped to evidence 0. So now, from an Explorer perspective, if I do a fdisk/dev host evidence 0, you see that the device is open in read-only mode, and I have my file system. So I can do, for example, mount mkdir /win7. So, sorry, first root mkdir, whoops, 7 mount /dev host evidence 0 /win7. False. Oh, sorry. I missed my demo txt, blah, 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 demo 2, we can hear evidence 1. No. Oh, the first 0, 7. Oh, version not permitted. Ah, sorry. Do like this. I do unmap like this. Map. I will map this one is D2. 0. Okay. Okay. I map to complete this. Map it to another one, right? The demo god is not with me today. Let's map this one on evidence 1. Okay. US status is D2. Whoa. And map this. And map this. And map again is D2. Okay, evidence 0. Why? Sorry for this guy. Why is it allow to bounce this only thing? I know. Okay, 2 seconds. I will just stop this. Sorry for this. Power off. I will use another version of the live seed because it's the one of the last one that I created. But settings. I will use another EV select. I will use Bitscode. This one. Yeah, this one is an old version. I don't know. Probably I have an issue with my tools. Sorry for this. Okay. Restart my session. It's normal. Okay, so restart. Go to my disk. I will do a map. I will map this one, SDA2, to evidence 0 read only. Okay. Here we go. So now I mounted my file system, and you recognize that I have access to a classic Windows file system. So program file, Windows, blah, 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 and so on. And then I can execute any tool that you normally execute to do forensic investigation. So I will go back to the slides. So this is the disk mapping in Access demonstration. So once you mounted the file system, you can use all the tools that you have, that your best toolbox. So you can use Loki, Bulk Extractor, Log to Timeline, all the Plazo. You can search if you have specific Python script. You can do whatever you want. So for example, I will show you how to use Bulk Extractor because it's an easy one. Let's run it a few seconds. So for me, Bulk Extractor, bin, the command, I prepared the complete commands. Yups. Okay. No, CD, where am I? Okay. Okay. So Bulk Extractor is running, so it's doing the job. I will keep it running a few seconds. So everything is running remotely on the machine. And which is nice because, for example, if the machine is a very powerful server and the live CD is booted, you will have all the resources of this very powerful server. So you don't need extra CPU, extra memory, and so on. You have the complete resources provided by the host. I stop this, and you see that in TMP bulk, I have already collected interesting information, domain, JSON files, JPEG craft, WinPE craft, WinDirs, WinLink, and so on and so on and so on. So you have access to all the tools that you normally use during your investigations. You can, of course, use the disk analysis tool. So that's the one that I just made. So the Bulk Extractor, Loki, and so on. But sometimes it's very interesting to work on a live file system. On a live system, it's easier because if the system has been compromised, maybe you would like to extract some payload to see the network activity. You would like to fetch some malware. You would like to extract stuff from the registries, but again, evidence must be preserved. So no, the next demo, I will show you how we can boot the compromised system using QEMU and always without changing any bits on the file system. So the goal is to preserve the evidences. So to do this, we have to perform two steps. The first one, we create a snapshot of the disk, and then we will boot a VM using the snapshot as main storage. So it means that the operating system will have a snapshot to write stuff, because when you boot an OS, it writes a lot of stuff, but you will prevent any change on the original file system. So to do this, I have to unmap my existing disk, because I need to map the complete disk, of course. Huh? So I will unmap this. And now I will map, yeah, it's mounted. You mount /15. Yes. And now I will map again, but in this case, I will map the complete disk, and I will map it again to evidence 0. There we go. So how to do this? The first step is to create my snapshot. And to do this, QEMU is very powerful. Oops, there we go. Let's create the snapshot. not visible on my screen. Oops. Like this. Okay. You see that it's very quick. So in a few seconds, QEMU created on my, where is it, on root. You see that I have my snapshot, which is very small because it does not contain anything right now. But I will now boot the system. So remember that it was a Windows 7 system. I will boot it in a QEMU virtual machine, and I will use this snapshot. So it's very long. So you have to script everything because it's a very, very long command like this, copy. So trust me, that's the command that you have to type. And what I will do, at the same time, I will check I need to map my VNC port. So what I will do, local, oops, like this, local host. So I need to map the ports to open the VNC console. Apps, second console. Here we go. So QEMU is started, and now I can launch VNC viewer, local host. There we go. Let's wait. It takes my VM is not very powerful, so here we go. So my Windows system is starting. So it means that on my live CD, in my Docker, I started a QEMU, starting a virtual machine, and the virtual machine, everything is running in memory, and I'm using the snapshot that I created to boot the system. So I do not alter anything on the original file system, and my system will boot. So you can now perform all the investigation that you would like to do. Like using the specific Windows only tool, checking for some evidences in a specific file. For example, if the file system is encrypted, you should be able to ask the user to type a password for you, so you don't know to have the password, but it will decrypt the BitLocker volume and stuff like this. So the VM is just running. I will keep the VM booting because it takes a few minutes. It's quite slow. Okay, so that's working with a live system. The next step, of course, is to take memory analysis. So well, guess what? We are using QEMU, so we are using a virtual system. So it's quite very easy to perform a memory acquisition on a QEMU system. It's only one command. And if the memory is very big, like 32 gigabits or even 64, even more on a server, everything will be located in memory on the Bitscode server. When I say in memory, keep this in mind. So if you start to do a lot of investigation and you start to create a lot of files, as everything is running in memory, it will be very interesting to have a very big VM with a lot of memory, more memory than the server that you have to investigate, of course. Is it? Yeah, starting Windows. I will continue to boot because I would like to take the memory image then. Starting slowly, slowly. It's a VM, it's a small VM with only one CPU. So can you imagine you have virtualization on top of Docker, on top of the live CD? let's try to get the memory dump, even if the OS is not completed. Oops, Control Z. See, normally we should already have some processes running. Okay, done. And now in /tmp, you have so it's a 1 GB file. So I have my dump. So now I can try to do some volatility stuff. Let's try to find the KGBD scan, to do the KGBD scan. So again, my goal here is not to explain you how to use volatility, what kind of artifacts you can extract from the memory image, but the goal is to demonstrate you how you can remotely have access to the memory dump, to the disk, to boot the VM remotely, to have access through VNC and so on, and you will be able to use the operating system like if you were directly connected on it. Let's keep volatility run. Okay. So that's the 5 demo, so the memory acquisition. What you can do, so if you need more tools. So for example, sometimes you need some tools that you did not prepare by default. For example, I'm a big fan of the sysinternals tools from Microsoft. Usually what I do, the sysinternals are pre-installed, so I have a version installed on my live CD, but the sysinternals tools are not installed on the Windows that you have to investigate. In this case, I will not do the demo because I'm running late, but you can also use QEMU. So how does it work? Basically, you can start a Samba server on the live CD. And when you boot the QEMU, when you boot the machine, you specify that a new SMB share has to be connected to the machine because there is an internal network which is ready to communicate between the live CD and the machine. So you can also exchange files, copy stuff. And then you copy the files on the MON directory and they will be automatically available on the live CD. It's coming up. But basically, I will just show you on the demo like this. So what you do, if you do this command, I will try to zoom. I don't know if I can zoom using text editor. Can I zoom? Let's try like this. So I cannot zoom. So basically, you specify, where is it? That you have a SMB server, which is running on 10.0.2.4. And you specify also the network that you would like to use for the file system, for the network, sorry, between the live CD and the Windows machine. And you will have a SMB share directly connected on the machine, and you will be able to investigate and to copy tools, to deploy them, and to take also to copy files between the SMB share and the Windows system. Other features that are also interesting. So as I said, communication is key. So it means that the live CD is able to communicate with a specific IRC server, which is private, and all the communication occur through the VPN. So the customer and the expert, the owner of the system can exchange useful information during the investigation. Another interesting feature, I don't remember when Peter from who made the talk. So Peter yesterday talked about Syslog NG, but he also responsible for the product Sudo, and Sudo has a nice feature when you can also work like like during the nuclear weapons launch. you can ask to approve some commands. So you need to have two people turning the key at the same time. The same feature is available in Bitscode. So it means that for some specific commands, you can ask approval to the customer. So it means that when you type a specific command, the customer, yes?
Yeah, so we are sorry, we are
out of time.
Can you finish very quick?
So you have just sensitive commands approval. It's another one, and I think it's my last slide. Yeah, you can of course use data transfer to do everything you want. So you can map all the ports, and you can download. For example, you can download the memory. You can always make a copy and download to the local system the memory image, the disk image if you want. You can also download through a proxy, what I do usually. So you don't need to use the internet connectivity of the customer. And yeah, I finished. So most important, Bitscode is developed and maintained by Vitaly. I'm not the owner of this tool. I'm just a contributor to the project. So it means that I submitted some changes that have been incorporated in the GitHub repository. But I really like the tool. I use it. I use the tool for projects and for investigations. And I was very happy to share this with you. So it's finished for me. So if you have questions, we are running out of time, but if you have comments, if you have questions, I will remain on the IRC channel. I will be on Twitter, so feel free to contact me and I will be happy to answer your questions. Thank you very much.
Thanks a lot.
And sorry for the small glitch during the demo, but I booted the wrong image probably, and because I'm building a new one, so it's always like this. Demo God was not with me today.
Okay, I just have a question. How can you deal with separate hard disk, like using a BitLocker? Is it possible to?
Yes, it's doable. This demo was a little bit out of scope because the goal was to present the tool with the basic features. But you can QEMU, for example, you can boot it in some kind of single user mode. So it means that when you boot the VM, it can be suspended, and then you can attach some debuggers. You can do a lot of stuff, and I have material to explain you how to, for example, decrypt a BitLocker key. So what's nice, because if you can boot the VM, you saw that you boot the VM and you can interact live with the VM. If your customer has the BitLocker key, it will just input the key for you, so you don't know to know the key. But if the system is completely locked and you don't know the key and you have to find the key back, there is a procedure to find. Basically, you use the classic procedure to recover the BitLocker key from memory, but it's doable, yeah, without any problem.
Okay, thank you. We have a last question given by Laurent. It seems that the preparation of the live CD needs quite some time.
Yes.
Are there pseudo automated scripts in order to automate the analysis?
The first time that you generate your image, there is a script and it will ask you some questions. What's the IP address of your VPN server? What's your SSH key? So very, very basic stuff. But personally, I made a lot of changes manually because I really would like to have my own customized live CD. But yes, if you have a simple setup, you have your OpenVPN server already available, you can prepare your own live CD in a few minutes. Yes, if you don't customize it, yes, it's doable.
Okay, thanks a lot for your speech.
Yeah, my pleasure.
Thanks. Our next speaker is Axel Simon from Red Hat, and he's going to expose some tools in order to hardening virtualization process on VM provider in a cloud infrastructure. So it's your time.
Hello, everybody. I suppose you can hear me okay. So yeah, my name's Axel Simon. I'm part of the Red Hat Office of the CTO. And today I'd like to tell you a bit about integrity and confidentiality in computing, and specifically a project we've been working on, which is called NARCS. So I'll share my screen. And yep, here we go. Let me know if everything is good for you. All right, I'm going to assume this is all good. So
Yes.
security, thank you very much. Thanks for confirming. By the way, I might skip a few things, but don't hesitate to come and ask as many questions as you want afterwards. We are an open source project, and we are very happy to have as many questions, people join, and everything. I'll say more about that at the end, but yeah. Anyway, so what's the problem we are looking at? Well, lots of people need integrity and confidentiality in their processes, in their data. I mean, this is a security conference. I'm sure I'm not teaching anybody anything new here, but these are a few places and sectors where people really have a strong need for confidentiality and integrity. You've got personal data, you've got health data, banking and finance, human rights NGOs. We don't often think about them, but they also need a lot of, they have a lot of sensitive data they need to protect. And for instance, one of the simple examples we like to give, but you don't necessarily want your sysadmin to be able to see the payroll information of your CEO if it's not public. There's a lot of cases. It's basically everybody needs to be able to protect data and to be able to protect the way data is managed and accessed. But currently, if you look at what a typical virtualization stack looks like in a cloud setting, it looks something like this. Each color here is a different vendor, a different trust domain, as we will be calling them, basically a different set, a different entity you need to trust. So your application at the top, maybe you've written that yourself, maybe it comes from a trusted third party, a free and open source project, you've audited the code. But all the steps, the parts below in the stack will be someone else, and you have to trust these vendors to be able to have a fully trustable stack. It gets very hard because you have someone different for the firmware, someone different building your BIOS, someone different building the CPU, and if any of these is compromised, well, basically you can't really trust your stack anymore. If you look at a container stack, it's even worse, arguably, because we have more places where there is a new person to trust or a new entity to trust. Your middleware and your user space will be one vendor, your container engine, your kernel, your bootloader, usually someone else. You have maybe even a hypervisor too in a cloud setting. So all these layers that you need to trust. Again, same problem, lots of different trust relationships. If any one of them breaks down, then you can't really trust what's going on. Any of these could compromise your stack and basically compromise your the data, the processes you're trying to protect. So not very nice. And one way of looking at it is this XKCD comic that many of us have seen. I don't know if you've seen it, but we find it very good. We like it. So maybe reality is not as bad as this, but it gives a good idea of what's going on. And this is the problem we have right now. I think honestly that this is a problem that so many of us find so hard that we've just sort of accepted it, and we've just almost put it a bit aside, saying, well, you can't guarantee all the parts of the stack, so just let's do our best. But actually, there is something we can use these days, and that thing is trusted execution environments. So what do they do, TEs? And we'll define what they are afterwards. But what do they do? So TEs, trusted execution environments, they enable you to create an area where you can put an application and its middleware, for instance, and to protect that. And how is it protected? Well, the CPU creates that protected area. And only the CPU has access to that protected area where you're executing things. So what happens if any of the other layers try to access this protected area? Well, they get blocked. They get blocked by the CPU, and basically all the other layers don't have their say in what is happening. So you end up with a stack, which is basically your application, its middleware, and the CPU. Those are the only things you really have to trust. Of course, you still have to trust them, and that's a big part, but we've reduced. We've reduced from, and let me go back on this for a second. Nothing's perfect here, but we've reduced from having to trust all these layers to only having trust a few layers, which is better. So looking at TEs a different way, it creates a protected area within the host where you can execute sensitive workloads. And what does it provide? Well, memory confidentiality. That is, the memory in which these workloads is loaded is protected. That's done through using cryptography. So the CPU will actually encrypt those pages of memory and will make them unreadable to any other thing on any other process on the host. It also provides integrity protection. So that means we can be sure that nothing is being changed in this area of memory without our knowledge. We can guarantee that the range of memory its integrity is protected. It also offers something else that is very interesting for us, the capacity for general compute. So this is where there is a real difference with a TPM, for instance. A TPM does not enable you to run anything you want. It's quite limited in what it will compute. Here with TEs, we have actually a general compute capacity, and they also offer a hardware random number generator, which is very useful for setting up proper cryptography and securing and creating keys and such. So all of these are very useful. But the first question you might ask if you're thinking of using these is, well, wait a second, how can I be sure that this thing on this computer that claims to be a TE, it really is a TE? It could be a rogue process pretending to be a TE and going to accept your workloads, but actually, not offering any protection. So the right way to do this, and what TEs offer, is an attestation process where you can, as a tenant, as a third party, well, second party, you can check that the TE is a real, valid, genuine TE and not an imitation. This is done through Diffie-Hellman public key exchange, and it's based on the hardware root of trust that is the CPU itself. So yes, this means you have to trust the CPU. It's a choice you make. It's a choice we make. Obviously, it has limits, but for the time being, we think this is a very good improvement. This is worth it. So what you do is you get attestation that the TE is a valid TE. By the way, this attestation can also be provided to third parties if you need to. That's another interesting aspect of it. And then you measure that everything is okay, and you can then start loading your workload in there. TEs come in two major models. So one of them is what we call the process-based one, which uses the process as a boundary. And that's what you will find in Intel SGX, which is not currently entirely in the upstream Linux kernel, but work is still underway. And it's also something that exists in RISC-V. It is a project being worked on called Sanctum. There's no actual hardware yet, but that's another TE model which is based on processes. On the other side, we have VM-based TEs. So we'll find this in AMD's SCV, in IBM's PEF, which also doesn't have hardware yet, and Intel is working on something. So in the VM case, we'll go back into it in a sec, but you use, as you may have guessed, a VM as the fundamental working block. Note that for our purposes, we're not defining trust zones from ARM as a TE for a bunch of reasons. I don't have time now, but if you're interested in that, we can always come and chat with us. We'll go more into it. So quickly going, we don't have that much time, so I'll go quickly on these. Some of the pros and cons from the process-based version. So you get system access to system APIs from Keeps. The Keeps is the name we give to TEs that we are using in NARCs, to TE instances. The cons is, well, you can't filter those APIs, and basically the major one is the security boundary is rather untested. It's a new one. It doesn't have years and years of research behind, and that is a thing to bear in mind. On the virtual machine side, well, on the other hand, the existing boundary, the VM, is well known, and we've been using that for security for years and years now. And you can essentially run your application on existing stacks. There's other pros, as you can see. But going quickly, in the cons, same as the previous time, you are sort of locked into the architecture because it's very specific to the silicon in question. You get some hardware emulation, and it is a bit heavyweight for microservices if you're just looking to run, really small services and microservices type. So knowing that we have these different TEs and that they exist and that they're out there right now, what can we do? How do we use them? Well, this is where NARCs comes in, and this is what we're trying to do with NARCs. And I'll explain a bit more the point of the NARCs project. So let's start with a simple five-point overview. So as I've just said, NARCs uses TEs, currently SGX and SCV, to enable you to run confidential workloads. One of the other big goals is easy development and deployment. And for that, we use WASM, which is WebAssembly. I'll come back to WebAssembly in the future, in a few minutes. But this is another big part of NRX. We want it to be easy to use, really, really important. Also, we have strong security design principles. And by that, I mean, we will try every time we can to make the decision to go for the most secure way of doing things and to prevent users from making bad security decisions. We want to give, of course, users the freedom to make choices, but as much as we can, we are going to make sure that you are by default making the right choices. And one of the ways we also do that is we use Rust, which has the same ideas, so it goes together. Very much cloud native. As you can see, we have a goal to support OpenShift and Kubernetes in general. So we want to make sure that integrates nicely with cloud environments. It's a big part of computing these days. And of course, this is a free and open source conference, and Red Hat is a free and open source company. So of course, NRX is a free and open source project. I will insist on project. We're not a product. It's not production ready yet, but it hopefully will be in the future. And as an open source project, it was donated to the Confidential Computing Consortium. So while it was started by Red Hat, it's not just a Red Hat project. It really is an open source project. And it right now is hosted by the Confidential Computing Consortium, which is a new organization that is hosted by the Linux Foundation. And as you can guess by the name, it is dedicated to furthering confidential computing at large. And it has hardware vendors, software vendors, blockchain companies, software companies. So, it's quite varied. It's a good place for that. So what are we trying to do? What's the goal with NRX? So this is basically the goal. The point here is that we want you as a client, so on the right side, to be able to attest that the TE on the host that you're about to put your workload on is a genuine one with the attestation handshake. Get an answer that shows you that this has been the case, that you can check that this is correct, and then reusing the encrypted channel you create during that initial handshake, send your workload and run it inside an environment, but with great ease. So we want this to all be as simple as possible. Currently, there are several projects out there that try and use TEs, but usually attestation is something that you're left to do on your own. And we think it's a really important part. If you can't check that you're running on a real TE, then there are real issues there. So yeah, the idea is this to make this simple. So looking a bit more in details, how we do this, I'd like to call your attention to the two middle layers, the blue and the green one, WASI and WebAssembly. So we want to make sure that you can basically you can compile your application to WebAssembly, and that runs no matter what TE is underneath. If it's a process-based, keep one on the left. If it's a VM-based, keep on the right. We want you to be able to write your application, compile it once to WebAssembly, and run it on a TE, whatever the TE is. And so WebAssembly here is a very interesting and important part. WebAssembly, for those who might not know, is something that came out of the browser world, and it attempts to do JavaScript done right. That's one way people have described it. Essentially, provide a fast binary. Can't really find my words here. Sorry. Essentially, it provides a target to which you can compile many languages, and that will run the same everywhere. It's again this idea of write once, run anywhere. But in this case, it seems to be really working out well. You can write your code in almost any language you want. I mean, you can go from Perl to Python, C++, C#, Rust. Basically, almost many languages can compile to a WebAssembly target. And that means you don't have to change how you're writing, what language you like to use, your tools. You can keep using all the ones you're using, but you can just compile to WebAssembly. And then we will, NRX take this WebAssembly binary and runs it on the TE. We're using WASI as the layer above. WASI is WebAssembly System Interface. It's a way of taking WebAssembly out of the browsers and making it work in server space by adding the necessary layers that you'd need there to access, for instance, things like file systems and such. So using those two layers, that's the NRX architecture, NRX plan. And what I'd like to show you right now is where we are for these two technologies, for SGX and SCVs, which are the ones we're working on now. So I'm going to do a quick demo, and hopefully the video will work fine through this through the presentation. So what we have now is we have these layers. We have the application, and we have the SGX T. So we're skipping the other layers, and this is how it happens. Let me full screen this. Right. So I'm going to show you the source code. So first of all, we have the source code to this application we're going to run. Very simple source code. Basically, just print a line of text. Good morning, that's nice to Netemba. We compile it to a static Pi binary, and let's check that it has compiled properly. Yep, okay, we've got a compiled binary. And now we're going to run it on SGX, and wait a sec, there it is. So it's run. Good morning, that's a nice to Netemba. So you can see simple source code. It gets run on the on SGX. That's quite cool. We're quite happy with that. Now let's do the same thing with SCV. So just as a reminder, SCV is a completely different technology. It doesn't use at all the same principle, not process, but VM based. Different silicon, different architecture, basically. So again, we take our application and we're going to try and run on SCV. Let's look at the video demo. So same thing. Let's check out the source code. As you can see, it's the same source code. We're going to compile it. All right. That it is. It's compiled. We're going to check now that it has compiled properly. Here we go. Same thing. It's compiled properly. Okay, no problem. And now we're going to run it. This time on an SCV keep. Sorry, an SCV T. And yep, okay, it has run. You can see. Good morning. That's a nice to Netemba. Same thing. Same output. Great. Very happy with that. The rest of the code is debug code. We haven't taken it out right now. This is still work in progress, obviously, but you can see same output on both sides. So that's really cool. So we're currently capable of running code on an SGX-T and on an SCV-T. So that's nice. It's nice, but currently what we've been doing is we've been compiling, and we've had to compile again. What we'd really want to do is be able to compile once and run the same binary on both. But actually, that's literally just what we did. That's what I just showed you. This was the same exact binary compiled once and executed on both sides, on both different Ts. So again, this is like really different T architectures. So this is a capture of the two terminal outputs I just showed you. You can see the differences, SGX on one side and SCV on the other side, but also some of you may have realized this, it's the same hash. So it's literally exactly the same binary. I know I'm repeating myself, but this is really quite an exciting moment for us. We've got one binary running on two completely different hardware architectures. So this is really nice. This is really cool. Obviously, we're not at the full picture yet. As you can see here, this is another version of looking at the whole picture of NARCs. We haven't done the WASI and WASM bits, but what we have done is the layers around. So our application is running via shim and a loader and the kernel on a CPU, on an Intel CPU in the SGX trusted execution environment. You can see, so the NARCs layers are include the shim and the loader. So that means we've had to write this specific code to be able to load in the process-based trusted execution environment on Intel CPUs. If you look at the VM side, for VM-based TEs, you can see the same general architecture, except that in this case, with the shim is followed by a loader, which is this time a virtual machine manager. So because it's a different architecture. So this is completely different code. We've had to write entirely different code for the loader on different sides, but we still get the same result. So this is where we are right now. A static Pi binary running on two different architectures with the using our code. The goal, of course, is this is where we want to be next. Is we want this to be a WASM binary, so a WebAssembly binary that would use the WASI layers to run the same on both sides. So this is the next step, and this will really make it even more useful. Where we are now makes it already possible for people to start playing with NARCs, and this is really something that's very very important to us, and I really want to invite everybody to join if you're interested. One of the core things about NARCs is that we are an open source project. Really, we try and do everything as transparently and as openly as possible. Obviously, among other things, for security reasons, because security through transparency is the only real way of doing this. But also because it's just a great way of doing things, and we really enjoy working with new people and having lots of people join and add diversity to the project. It's been a really great way of having new contributions and new ways of looking at things. So yeah, everything is open. You can see here, code, wiki, design, issues is all on GitHub. We have a chat on Rocket Chat, which I'll put a link on the next page, and we welcome you. We have CI/CD resources that's running on Packer.io because we need specific hardware. We have daily stand-ups open to all. Anybody's welcome to join. And we use the code of conduct, the contributor covenant, to make sure that everybody plays nicely, because we all want to work together and have a nice time. So yes, join us if you're interested, by all means. The website is narcs.io. It's going to change to narcs.dev in the near future, but it'll work anyway. The code is on GitHub. The chat is, I thought it was on this slide, it should have been. It's chat.narcs.io. Everything is licensed under the Apache 2 license. Almost everything is written in Rust, except for some parts that were written in actual assembly for the loader. Yeah, that's it. Please join us. And one more thing, as you might see here, yeah, we still have bugs. Of course, we still have bugs, so please, come in and join if you want to be part of this. All right. I hope I wasn't too quick, but very happy to have some questions if you'd like.
Thank you.
Thanks a lot for your presentation. I have two questions. The first one is, what is the impact on the performance of the programs?
So that depends on the TE you're using itself. Currently, it's a bit limited what you can do, because you can't run, for instance, a whole MySQL database in a TE. I think, if I'm not mistaken, SGX has a maximum of, is it 128 megs of memory available at a time? And the VMs, this is something I maybe didn't say enough, but you shouldn't envision the VMs as normal VMs, which are going to be running a whole operating system. It's more just a virtual CPU with some memory pages. So right now we're thinking about smaller things you're going to be running in TEs, not an entire operating system or an entire database. That doesn't really answer your question. From what I can tell, it's a bit slower, but it's not hugely slower. So sorry, it's not a very precise answer, but this is what I can tell you right now.
Okay. My second question is, do you plan to deploy this solution on the cloud solution by IBM?
Yes, I suppose. I mean, this is an open source project, so anybody can use it. But beyond that, I think it would make sense. I mean, this is something that we think is going to be one of the next steps. Lots of people are going to want to be able to use this, because what is interesting here is that it protects you on third-party clouds, like cloud vendors, but also on your own cloud. You can't always trust the sysadmins on your own cloud, and so this is useful in any cloud. So yeah, we expect to see lots of uptake. If this works out, lots of people will be interested, and we'll try and put it in their clouds.
Okay, thank you. I think that we don't have another question. So the next presentation will be in around 5 minutes. Thanks a lot.
Thank you very much.
Bye. Good. We're going to do our next presentation. So now the speaker is Olivier Lambert, and he's going to talk about a specific security issue in a virtualization environment. So you can start, Olivier.
Yeah, sure. Thank you. So can you hear me well?
Yeah, it works.
Okay, nice. So I will share my browser. This one. Okay, so can you see it?
Yeah, perfect. Thank you.
Okay, great. So let's go. So indeed, as you said, I will talk about today security issues related to the virtualization world. First, I'm Oliver. I'm the CEO and co-founder of Fates, a French company based in the Alps in Grenoble. I'm a former system administrator and a Zen user since a while now. I also created the Zen Orchestra projects 7 years ago as a web UI to manage a Zen server, which is a virtualization platform made by Citrix. And 2 years ago, I decided to fork this platform to make XCP-ng. We'll talk about that later, but I can tell you that right now XCP-ng is part of the Linux Foundation project, and everything is open source. Those slides are available right now on this link on vates.fr/PBS. So if you want to get them in the meantime, I'm doing my talk, feel free. So you could click on the links and, take things a bit deeper if you want to learn stuff. So a quick recap on virtualization. So you are probably aware because you are the kind of public knowing that, but it's a kind of a reminder that virtualization is still everywhere. Because you might heard some, people, CXOs telling that everything is in the cloud and it's container, etc., but they tend to forget or don't know that in the vast majority of use cases, everything is running on top of virtualization. So you got the hardware, the virtualization platform, and then everything on top of that. So it means it's kind of a commodity. So it's everywhere. That's great, but it means because it's everywhere, there are some responsibilities that we have as software editors on virtualization platforms. So those new challenges, they are related to, and this is interesting because it makes sense with the previous presentation, about the whole stack security and having all the components in the stack to be secure or nothing is really secure. But you have also challenges regarding CPU security issues and mitigations against that, and also new use cases that are really interesting, but also means you have new challenges in those areas. So regarding the whole stack, I think you are all aware that we are, going far away from the middle because, it's easier to do some stuff by being, on the shoulder of the previous work that's been done. So we have virtualization, public cloud, then we got orchestration platform, then containers, often, as I said, almost every time running on top of virtualization, then container orchestration, then even serverless, as serverless to developers, and even developerless, which is not a joke. I can assure you there's some no-code trends sold by some editors, so you don't need, to understand anything to build an application. So what's next? The thing is, we are going away from the middle, and we forget that everything is running on a server in the end. So that's what matters. And the other problem in the meantime is the fact that hardware vendors like your, server vendors like Dell, HP, or whatever, are increasingly putting software inside their, hardware offer, like, more firmwares, more BMCs, like, iDRAC or ILO. So those really great things to facilitate the way that you work with your servers, but those teams are, don't have really the security culture bundled in, and they have often other priorities. So it's like, if you want to compare, like, the car manufacturers, they were deeply hardware, vendors doing really big work on physical things, but there's more and more software in your cars, and then they don't really have this culture of building software, so it might cause issue. And guess what, it did. So regarding CPU's problems, you are very aware, I suppose, about all the recent Intel, but also other people, other founders like AMD, or even on ARM thing. There's gone some, I would say, at least small problems regarding branch prediction and kind of shortcut that you can do to have faster CPUs, but in the cost of being able to break layers, to break security between virtual machine, between application. So I won't do an exhaustive list of all of them, but there's a link if you want to go deeper. It will take you to the paper, so you can learn a bit more about that. But the main thing to remember is those problems are really related to some shortcuts some people did to have fast machines, and then it breaks boundaries between VMs, thread, or programs. Regarding the IPMI BMC's vulnerability, so again, an IPMI is a chip or even a small computer directly within your server, and those chips are really, really great if you want, to do a remote hand installation, make some changes into the UEFI, mount virtual devices, update firmware. That's really powerful and really useful. But the problem is, when this is compromised, then it means you are completely compromised, because they are so low level that you can access almost everything for them. So this is also a kind of threat. So in that context of more and more complexity, more features, and more low-level software available, it means that it's the time when you bought a server and you put it in the rack, and that's it. You won't touch anything else except the operating system on top of that. This time ended, since we had all those issues on Intel CPUs. So there's a lot of stuff now you need to update, like microcode, firmwares, PMCs. You might even tinker with the hardware by removing, for example, hyperthreading if you think it's worth it in terms of security. And the problem is, those bugs are here to stay. By that, I mean that it won't be solved, and I'm pretty certain that in the near future, we will find other, kind of similar security issues on those. So it's really hard to trust that anymore. So you really need to think differently when you are building software on top of that. So as it was said on the previous demonstration, previous talk, all layers are really important if you have something that you can trust. So, okay, this was the context. So what about the impacts on virtualization now? Because we saw that it's going more and more, difficult to have something secure. And what about virtualization for that? So the problem is, if you start to make mitigation in your, for example, hypervisor, then it could have a cost. For example, you can just choose to disable hyperthreading, but you can also make some other choices that will, for example, walk around some calls into the CPU, but then you will lose performances. So you must leave the choice to the user, to be able to select if he wants. If he doesn't trust the environment, if you are in public cloud with, for example, noisy neighbors, that kind of stuff, you might want to be really strict on security. But if it runs entirely internally, then you can make your choices. And obviously, if you want to keep virtualization, you need to have a low overhead. So you need to work on the performances. On the purely compute side, or the hypervisor side, this also, this challenge will push you to work with more CPU isolation features like ICV, SGX, and that kind of stuff from AMD, Intel, or whatever, but this required to integrate those kind of new possibilities directly into the hypervisor to enjoy those new way to isolate your virtual machine, for example. But also you need to think big in the way that there is more and more cores coming, for example, on recent AMD CPUs. So all this work will also have an impact on the performances. So, and this will be far more complex, to tune for for example, for specific cores or for specific machines. So it's even more complexity. And that's not all. It's just don't stop on the server virtualization world, because right now we are seeing virtualization pushed, in the embed world or in the edge computing world, which is really, really interesting in the way that, people like to have flexibility directly on the field. They can, respawn VMs directly for a small machine that's running to a factory, and that's great. And you can have really great features by doing that. But the thing is, you have to think about surviving into a hostile environment where, into the factory, some people could even steal the box or access physically to the box. It's not a data center anymore. So again, it's another thing to think when you are building a virtualization platform. Another, I would say, interesting topic to explore. There's also new CPU architecture that could, be a game changer. It's hard to be really sure it will, execute. But in the end, if you don't have, the dependency against a completely closed microcode, then you could probably build a platform that's fully open source from the hardware to the application. And that's why it's really interesting. And that's also why you need to keep all of those architecture on your radar if you're working into the hypervisor industry. So specifically for the virtualization, the way to tackle all those problems, there is, I would say, in my opinion, there's three main ways to do that. The first one is the obvious one. I'm an engineer. I think there's a lot of people here who are also engineers. And the first thing that you are thinking is, okay, there's a technical problem. I would find a technical solution. So that's great. This is a way to cope with those issues, but it's just one part. I would say even 1/3 of the way to find a solution for these challenges. So that's why we all see also other solution. But first, let's go to the technical solution. On the technical side, because I said a lot of things just before about all the complexity and the need to adapt quickly, then your code should be able to adapt to. So when you are building the hypervisor, you need to be modular. It's the end of the time of when you are doing something for just one platform. The great challenge of, I would say, general purpose hypervisor is to be able to deliver something that will be working for the user need depending on the user hardware, and you should be able to select what kind of the hypervisor you want to use. So you need to rethink a bit how it's done and to make somehow like kind of plugins, if you like. So some people would like to run stripped down versions, for example, of the hypervisor. So for them, it's called OpenXT or CubeOS, or having the whole full spectrum of security features enabled or disabled regarding their requirements. And you need to have a good documentation to do that. So technically, you must have something that can be really modular. And that's not it. Technically, you must provide a way for the users to enjoy an easy way to updates, because as you know, there is more and more security issues found, and the whole world, especially in the software, is going faster and faster. So you need to react fast, and for that you need to provide patches really fast. And if it's a pain to apply, then your end user won't apply their patches, because it means it's too much work. And if they're patched every month, then they can't keep up the pace, and they will let the solution like this, and it will with a lot of flows. So it's also your responsibility to build something that's really easy to update. So for that, there is on Zen side really interesting features like late microcode loading, so you don't have to reboot if you load a new microcode into the CPU. Live patching, so you can live patch Zen to get the latest security patches if you like, without any consequences on your virtual machine running on the host. And there's even the hypervisor live upgrade, which is switching from a Zen version to a new one within the same host without any virtual machine interruption. So that's really a really cool use case that AWS did, contribute to. There's a link if you want to read the paper. The concept is pretty powerful and interesting. But also, a more general thing, the technical solution are also research and development. By that I mean finding concrete solution to overcome the security issues that we can have on the hardware. So it's not an exhaustive list because it would have been really very long, and explaining all of them into great details would take days. But to give you some ideas and some leads to dig if you want to know more, interesting stuff are, for example, core scheduling. It's a way to keep the VMs on the same physical core despite having hyperthreading. So you will limit the chances of leaking data between, branch prediction problems that you have on, for example, Intel CPUs. Disaggregation is a way to have more isolation, like a defense in depth. If you are losing the network side or the storage side, it won't compromise all the compute side, etc. Or even, having a hypervisor that's where even if you are, getting it if you hack it, then it won't leak any secrets. So those are some technical solutions that are really worked on by Zen developers on the Zen side, because this is the hypervisor I know the best, and there's people, really talented people working on that from Citrix, AWS, or SUSE, or really big users of Zen at scale. So other really important pieces of that are organizational solution, like improving the process, because you have more and more, flows, more and more security issues because of the hardware, or even, in your software, you need to have a process. And this really a central piece of thing in your project, in your open source project, is if you have a good workflow when you have a security issue, and the Zen one is really great because, again, this is used by big cloud vendors, so they had to agree on a way to work with that. You had a checklist, you had a way to make to communicate around that, and this is the process is vital to be able to cope with those security issues. But also, because it's open source, you can use the community, and that's really great with open source, because you can meet people, having a discussion with them on the field, discussing with end users, but also exchange with other open source projects like KVM or even the Linux kernel. And we love to do that inside the Zen project, because it's, for example, for core scheduling, it was first in Zen, but the design helped to build it from KVM guys' input, etc. So that's why it's really important to collaborate at scale. And obviously, being inclusive, especially for security people, to be friendly to them when they come to assist you regarding projects. That's vital. But also, another thing that matters a lot is, okay, you got a technical solution and you got a good process, but then you need ideally something where all of that is integrated. And by that, I mean a solution or product, if you want to call this that way, but something that's been able to gather all people from different projects to deliver something that can be easily used. So something that's able to federate people around it with some for example, processes, or being able to have a way to secure things by default, because it's a good way to do things, to be secure by default, and also to have people able to work across boundaries, across, for example, the compute world, the storage world, etc. This is really important, to be able to have people working on multiple components at once. So to give you an example, I'm telling you about that because that's the kind of stuff, and I would say exactly the kind of stuff that we are doing with XCP-ng and Zen Orchestra. So again, XCP-ng is the Zen distro. If you like a Linux distro, but it's based on Zen. It's working out of the box. You just download, install it. It's bundled with different projects like Zen Linux, Open vSwitch, got an API on top of that, and it's fully open source. Everyone can contribute and is very welcome to contribute. And on top of that, you got the web management thing to do all the operation on top of it. So our work with this project is to build bridges, for example, between communities, so you can bring people together to work on your, on the solution, because sometimes having, developers and end users communicating together is not something really easy. Federate other projects from inside, as Zen or the API, or even outside, like other distro that can be better integrated into the virtualization platform, being secure by default, as I said, but also having a lot of work, and we are doing a lot of work regarding research and development, for example, secure boot or improve the performances and that kind of things. So by the way, if you are interested to do that kind of research, we are hiring. So yeah, the goal is to have a turnkey solution in the end that might help to do all those, to tackle all those security issues. I mean, we are not the only project doing that, but this is really important to keep in mind. That's not just a technical thing, but really a way to organize stuff around it. So in conclusion, broadly, not for XCP-ng or even Zen, but virtualization will see more and more challenges coming than ever, more security issues, more complexity on the physical layer. And we and all the virtualization editors need to keep the pace, because it's requiring a lot more collaboration than ever with even hardware vendors and with researcher, with PhD, with academic world, and all of that needs to solve the security problems, but also limit the overhead. So you also have a performance challenge that's really interesting to try to solve with that. And what's even more interesting is that we are seeing in the market, I would say in the market in general, that there's more new companies trying to do innovative stuff on the lower end, on the side, on the more hardware stuff. So there's some companies trying to build even CPUs or more integrated hardware, etc. So that might be a great opportunity that people start to really think about. We have problems with this hardware, maybe we can do something else, and this is where virtualization might be also work together with those persons, because it might deliver some really awesome products. So this is it. In the end, it's really exciting time for virtualization more than ever, and we are really happy if people want to do that with us. And if you have any question, feel free to go ahead, and otherwise, thank you.
Thank you.
Okay, thanks so much for your presentation. I have a few questions on
Sure.
all participants can still use the Q&R button in order to ask for a question. What XCP-ng offer in order to improve the security?
So right now we are, so we took something that already exists. For example, as I said, it's a fork from Zen Server. So we are using some existing security feature from, Zen Server. So as you may know, Zen by itself is really interesting in the way that isolation is made. So by default, I would say by design, isolation is pretty nice, but we are working right now to improve, for example, all the secure boot capabilities, both from the guests, from the VM, but also from the hosts. And for that, we are working with really talented people from different companies working on different projects, like, for example, Trench Boot, or even, a similar project where security might be really important. And to be fair, the Zen project itself, because Zen is the engine, that we are using in XCP-ng, but it's also used by a lot of different companies where they're, for example, working in a very, security-oriented world, and the work they are doing is, being considered and probably will be integrated inside XCP-ng. So there is a lot of different techniques, that you can use, as I said, like core scheduling that might, raise the security, using TPM, measure boot, etc. So there's a long list of possibilities. And I think to answer your question, that somehow people thought that virtualization was something a bit static, that it's there and it won't move anymore. But it's exactly the opposite. There are so many things that are going on right now in the Zen world.
Okay, thank you. My second question is, ARM processor seems to be more and more popular, even in the server environment. Does it modify something about the security in virtualization?
So, so you are talking about security and virtualization for other CPUs, other architecture? Well, for now, I can say about XCPNG is for now we are only x86 compatible, but we are keeping an eye on other architecture, like you said, especially since Graviton 2, which is a specific SOC made by AWS that's not available in the public, but still it shows that you can start to have really nice performances on the server for outside the x86 world. And I know there's some security, hardware security things in ARM. I think we've seen some of them in the previous talk, but I'm not an ARM specialist. What I can say is there is indeed some traction to do things correctly, because ARM was, trendy maybe 8 years ago, and people even like me thought that ARM will be on the server in a matter of, months, but it didn't happen. So we'll see what happened. But also other architecture are on their radar that might be really interesting, like RISC-V, because it's fully open source, and that's why we are, trying to start to port Zen to RISC-V, but it's a long run thing. But we would like to have this because in the end, because we love open source, that would be really great to have a fully open source platform from the hardware to the applications.
Okay, thank you much.
You're welcome.
So we have a little pause. The next presentation will be in 50 minutes. So see you soon. You can have a coffee break with Figolu if you want.
Good point. Good point.
Hello. Okay, so we can continue for this afternoon. So the next presentation will be from Damien Coquille from Digital Security, and he's going to speak about the wars of the machine. So Damien, you can start. We don't hear you.
You are muted.
You have to unmute your microphone. Good.
Okay, it's good now?
Yeah.
Better,
Okay.
thanks.
You're welcome. I'm going to share my screen. I don't know if it's okay for you. Okay, can you see my screen just to make sure that everything is okay? Okay, so here we start. So yeah, I'm going to talk about Wars of the Machine, or more precisely, how you can build your own SIG industrial robot with open source technology. So who am I? I am a senior security researcher at Digital Security. Just to make things sure, I'm definitely not a machine learning expert. My field is mostly security, but in this talk, I'm going to dig into this machine learning stuff. And I love learning new stuff. So this is just all about me. And let's start with a small introduction. So during the lockdown, I looked at machine learning and since a month before, and machine learning is cool. You know, it's always something. Yeah, it's something amazing. It amazes me every time I see this kind of stuff. You know, people doing things such as an application able to spot hot dogs with a smartphone. So yeah, this is something awesome. And if you have a look at what China does with machine learning, and especially with some, well, you can see, we can say non-ethical things with machine learning. So this is again quite amazing. They are able to spot people on webcams, on cameras, and surveillance cameras, and cars, and so on. So this looks awesome, and this came into my mind that what if I try to do the same with all the tools I can have or I can find on the internet. I was also amazed by deepfakes. You know, this technology that is able to put, say, another actor face on people in an advertisement, for instance. So this one is Rowan Atkinson's face on normally an actress playing in the ad. So this is something again interesting about machine learning. So it was said I was going to learn machine learning, so that's a challenge for me. Like I said, I'm mostly in the computer security field, not in the machine learning field. I have absolutely no clue what I'm doing, but never mind, I will learn about it. So I decided to start with a little project in order to experiment this machine learning stuff. I needed to start very small. You know, I didn't want to go into a big project that would take time to complete. I needed something small. I needed something that would give some results very shortly, because I'm this kind of person, you know, who needs to get results very quickly in order to know that I'm on the right track for this. And also, I need something related to IoT security, because like I said, this is my field. This is something I'm into since ages. So obviously, if this little project could help myself finding some or creating some kind of tool that may be useful in my today work, this could also be very interesting. So what about a tool that would be able to give a big picture about IoT security and IoT devices that one can find on the internet? Why not? So I started with a small feature list. In this feature list, the first one was to be able to scan and collect information about devices from mostly HTTP services, because these HTTP services are very, very popular in IoT devices exposed on the internet. So this is one way to find some smart devices on the internet. HTTP is very, very common. I want to this project to be, or this tool to be also able to classify these devices. So to put them into groups of similar devices, and to do this automatically. I didn't want to review thousands of devices or web services available on the internet by hand, because it would take time to do it. So I decided that this tool must be able to classify this device by using machine learning as well. And this tool is, should also provide an overview of customer premises devices available on the internet, like be able to make some stats out of the collected data and so on. And the last point, and this is something very interesting, I guess, because we can use also the same technologies included in this tool to maybe create targeted attacks. Just if you want to target some kind of devices in an automatic way with some kind of robot that will scan the internet and find interesting devices and then attack them, collect information, do something nasty with these devices. This is the same way. We can achieve this by also the same technologies. So yeah, I was not sure about this last point, but in fact, this could be interesting and fun. I searched internet about previous research and previous work. So I found a paper published at it's also a presentation published last year at Usenix about an analysis of IoT devices on home networks. And this paper contains some machine learning tricks the author of this paper made to determine what are the most popular devices in people homes. And also another paper about Profile IoT, which is a machine learning approach for IoT device identification based on network traffic analysis. So again, this is done at the network level. So we need to capture traffic between the devices and the internet to be able to categorize these devices and to classify them. But this is not what I need because I wanted to be able to detect and classify these devices based on the exposure of these devices on the internet. So the main question is, how is it done? How one can use machine learning to get this this tool designed? So this is maybe the main question. So I looked at all this machine learning trickery, and it's at first it looks quite interesting because the main question about machine learning is how can we make machine learn? How can machine learn? Because this is almost the answer is pretty simple. This is the same way as our brain learns. We are going to teach the machine how to do a small task, and then based on the trained machine, we can get result from it. So this is quite obvious because this is machine learning. There is this learning term in this machine learning stuff. So this is obvious, but technically this is not so obvious. So first thing first, we are going to train and try to predict an answer using machine learning. So this is done by training a machine to do a precise task. For instance, I want a machine to be able to tell if there is a cat in a specific image. So we give the machine an image, and this machine will be able to answer this question: is there a cat in this image? So how do we achieve this? By training the machine. We give this machine a lot of cat images, and then this machine will learn to recognize this kind of images. And if we present the machine with a random image of a cat or not a cat, then it will be able to tell if it's a cat or not. So this is what we call supervised learning, because we need to provide the machine with a specific set of images that corresponds to the correct output, and also other images that do not correspond to this output. So we are going to give this machine a horse image and tell this machine that's not a cat, obviously, and so on. So this way the machine can learn and give results. Technically, how it's done is done using some kind of neural network. So the main concept of neural network and main implementation is a perceptron. So this is basically some neurons interconnected with different layers. And we give on the left side of this image, on this neural network, we give some input data, and the system is going to compute some weights between all these neurons in order to propagate the information to the output, and the output will tell the correct answer. If it's not the correct answer, then the system will be corrected, will be fixed by using some kind of backpropagation, and the weights of the connection between all these neurons will be adjusted in order to give the correct input. So the more input you give to the system, and the more reliable you get, the output will get. So this is something not very tricky to implement, but as we are going to see later and put in this presentation, this is not really, this isn't really important. So you get a lot, you give the machine a lot of cat images and it gets the correct result. You can also ask a specific machine to classify data based on a specific data set. So if I ask a machine to sort a set of images, just like animals, for instance, I expect this machine to put dogs in a group, cats in the groups, horses in other groups, and so on. And the way it works is that the machine will find similarities between these images and group them. And mostly this kind of system is able to find relationships between data inputs that is not really trivial, and then make groups out of them. So this is something I could, yeah, it's for humans, it's very difficult to perform this kind of sort, but for machine, this is quite obvious. So this is what we call unsupervised learning. So this is called unsupervised because there is no human involved in this process. We let the machine do the job. So for example, and if we want to sort a set of data about vehicles, then we are going to describe each vehicle with the number of wheels and seats, and let the machine do the rest. So if I give some images of these machines with the specific data, number of seats and wheels, then this machine can group or can create groups of similar vehicles and then give me the answer. But the machine cannot tell that this is a plane or this is a car. This machine just gives me groups of similar items. This is done technically with some clustering algorithm. So this is the most, not the most simple, but this is one type of algorithm that is currently used and usually used for this kind of stuff. This is k-means clustering. So this is very basic. You know, you put your data point based on the characteristics. Say, for instance, on the x-axis, you can put the number of wheels, and the y-axis, you can put the number of seats, and then you plot your vehicles on this map. Then you are going to put some centroids, what is called centroids. This is basically a point in this two-dimension space. And these centroids are going to move toward the nearest group of items based on mathematical computations. And once these centroids are placed in the middle of the group, then all the items near the centroid will be categorized, will be grouped. So the result is that we get some groups of items, but we have no clue what these items are, just that they are in a way similar, or it exists a link between them. And this algorithm is quite interesting because it's based on a number of centroids, which is set at the beginning. So you need to know how many groups you're expecting in order to get valuable results out of it. If this number of centroids is too low, groups will contain multiple subgroups. And if it is too high, then a group can be spread among multiple centroids or multiple groups, and you have to sort it again. Data will be spread, and it's not really useful. There are also other algorithms I won't cover in this presentation, but in fact, these are some variants of this k-means algorithm, or something very different. But the k-means algorithm is one of the most used, as I saw on the internet. So just to sum it up, we have supervised learning versus unsupervised learning. Supervised learning is for training. We need two data sets, one for training, one for testing, and we can create these two data sets from one data set. And the unsupervised learning finds relationships or links in chaotic data. So this is what we're going to use later. Again, supervised learning is simple and effective. It's not very difficult to implement. It's quite straightforward to run. Unsupervised learning is more complex and more subject to errors because there is no human involved in this process. So we let the machine does the job, we let the machine do the job, and then we get the results and see if it fits on it. All of these algorithms use datasets. Datasets, it's basically a bunch of data that is provided to this algorithm. And these datasets should be correctly created. If not, it could lead to errors. And these datasets can also be biased. If data picked to compose these datasets are not correctly chosen. But and again, if you try to split a single dataset into two other datasets, training set and the testing set, then you have to do it very carefully in order to get valuable data. These datasets are composed of what's called a feature vector. A feature is a measurable characteristic of our input data. So this is some kind of mathematical value that we can give to this algorithm, and that will feed the learning process. The feature vector, this is an n-dimension vector containing these features and representing a single point in this n dimension. So this is an item of this data set. So that's mostly the theory about machine learning. So my first question was how to turn data into a feature vector, and most of it, how to collect data. So I started developing this project by scanning, by creating the scanner, which is the basic of this tool. So this scanner scans the internet for well-known HTTP ports and then collect valuable data. All this data is stored in a database, and we will see later how to turn or to convert this data into a feature vector. So creating our dataset is quite easy. We just scan all the internet looking for HTTP services. We grab the HTTP headers, body, and we also take a screenshot of this of each device. So this is very easy to do with Python and the Pythonic request model you can use to send HTTP queries to remote services. We are going to use Chromium and Selenium to drive Chromium and take screenshots of the remote services. So everything is quite straightforward. This is obviously something very easy to do in Python for a person who knows Python and these models. And I started grabbing data from all over the Europe. So I scanned some system in Spain, in France, in the United Kingdom as well. I had no problem, no issue with France, Spain, and Portugal. But I found some more stuff in the UK, and I got banned from a specific ISP in Germany because I was sending too much requests to the routers. But anyway. Since I was doing this from home and I was not using any server, I think this is expected. So as a result, I collected 4,901 pages from various devices from many countries in Europe. And if you have a look at the screenshots I made, you can see that there are some devices that are quite the same, but others we have no clue about. So this was quite interesting. So now I get all the data in my database. I need to turn this data into something which is a mathematical representation of this data of each page in order to create my feature vector. So how to measure a web page, how to convert a web page into something that can be used to feed the machine learning algorithm. So first of all, you can get the content length, which is basically the size of the answer from the remote service. So this is usually the same per device if it's an IoT, but it's not always the case. We can grab the number of headers as well, written by the HTTP service. We can get also the number of scripts, images, and other tags present in the HTML page. And these are something that is easy to get from a web page. If you want to do it in a badass mode, you can also get further mathematical values, such as the Levenshtein distance from the web page you have gathered between a reference page. So this is basically a score computed based on the similarities between these two pages. You can also analyze the document object model structure by flattening this structure and compare it with the reference structure by measuring the Levenshtein distance between them. And you can also get the size of the normalized page text. So you strip all the tags and you keep only the text that are displayed on the website, on the web page, sorry, and then you get the size of this. So this is more difficult to compute, more difficult to get, but this could be interesting to implement our classifier. So yeah, Levenshtein distance, I thought about it. So based on this, I converted all my data into a series of numbers that can be analyzed by a machine learning algorithm. So it was time to start my automatic classifier. So I decided to use scikit-learn because it's the most common Python-based machine learning framework built upon NumPy, SciPy, and so on. And this framework provides everything we need to do machine learning. First things first, I started by converting my records from my database to a structure that is compatible with this framework, which is called dataset. I used some module called pandas to do this. So basically, I extract the valuable data for the machine learning algorithm from my database. And I get headers, number of headers, number of meta tags, sorry, number of script tags, image tags, and the body size, which is basically the HTTP answer size, which is the content length. And I decided to implement the k-means algorithm for my classifier. So basically, we create a data set from it, and we run this classifier. Remember, the number of centroids matters. You need to pick the right number. I tested this system, this tool, with the number of k of 100, and it didn't work pretty well because I got a lot of various devices in one group. I tried it with 1,000 centroids, and it gave me too much results with many devices, similar devices spread among different groups. I also tested the badass feature vector with the Levenshtein distance and so on, and it gave me a lot of false positives because, you know, a lot of pages look the same. So structurally speaking, when you have a look at the HTML code and so on. What gave me the best results was the basic feature vector based only on the specific number of tags and the number of HTTP headers and so on. So badass is not the best. I thought that it would give me better results, but in fact it did not. Because it's too complicated. So just stick to the intrinsic characteristic of a page by keeping the content length and number of tags and so on, and by using a number of 500 centroids in my case, and it gave me a very good results for this k-means algorithm. So I ran the system upon my data set collected. So remember, I grab all the data, convert this data into a data set with mathematical values representing each page, and then I get groups. I get groups of what is supposed to be similar devices, but I need to sort them. And I decided to add metadata to keep tracks of this item. So I'm going to use to add a category. Can be network access storage, wireless router, and so on, a vendor, product name, and so on. And I decided to also do this by using machine learning. So this time we are not going to use some unsupervised classifier, but we are going to use supervised learning because we need. By using this, we'll be able to automatically add this metadata. But we need a reference data set with verified metadata. That means I need a data set with non-results, with metadata already associated to this item. So I decided to create a small interface, a small web interface to add automatically metadata to this. To the system, and then I was able to review all the item, remove all the false positives that have been reported by this system, and then I was able to add automatically for the entire group to add some metadata and save this metadata into the database. So by doing this, in a few hours, I was able to sort everything out and have my reference dataset. So then it's possible to train a model for each category. We create a perceptron for each category, and we need to have enough input data. So this is why I chose the most common category I have in my dataset, which is the camera category. So based on this, we create a dataset and another set, which is the result set, which is the expected result set we're going to use to train this perceptron. And again, with scikit-learn, we create a MLP classifier, which is a multi-layer perceptron classifier. And we train this perceptron with this dataset. And by doing this, we get two things. We get a standard scaler, which is used to standardize the values of my dataset, and then a perceptron, a trained perceptron that can be used later to predict outputs. So these two values, this perceptron and this scaler, can be saved for persistence on a disk. So I saved this into the camera.model file, which is the model that can be used. And I tested the accuracy of my model, which gave me something like 94% of success, which is not that bad. And I was pretty amazed by this result because I didn't expect that much from this quick implementation. So here's the workflow of my system. So first I collect data. I transform this data into something compatible with machine learning. I have an unsupervised classifier that will split this data into groups of similar items and automatically add metadata. And then I, human, validate all this information, and I can add some metadata as well. And with all this information, we can improve the models for each category and improve the classifier as well. And we do it again with the newly collected data. So this is something that is pretty automatic, but it still requires a human to validate all this stuff and check it. Check if everything is correct in the database. So I run this system on a lot of machines, a lot of services. So remember, I collected almost 5,000 web services hosted on DSL IP addresses. My tool helped me a lot to sort this data, because my classifier was able to group every similar item, and I was able to define a lot of categories and a lot of products in this database. This is a small data set, 5,000 web services. This is not that much, but it seems accurate in a way that I spotted a lot of various devices, different services all over the internet. And I guess my results are not that bad. So just to sum it up, my raw data, my input data, I have 4,895 web services detected. I ran this through my classifiers. I was able to classify or categorize 1,501 devices. My system took 3,152 screenshots, which is weird because I should have the same number of screenshots at the web services. I don't know what went wrong during my scan, but in fact, something is not. Did not happen as expected, but anyway, and I got 34 megabytes of HTTP answers from various web services. I ran this through my classifier, and this is a result by category. So this we have 34% of IP cameras, 19% of network attached storage, 15% of DVR, which are digital video recorders, 11% of routers, 9% of ICS, 9% of wireless devices, and so on. So the most popular categories, as we can see, exposed on the internet by by people in their house. are IP cameras, network attached storage, and DVRs. So this is somehow what was expected from the raw input. I looked at these devices during the scanning process, and this is mainly what I saw. So this makes sense. The top 5 vendors, the first one is Hikvision, which is an IP camera vendor with more than 300 devices. The Dahua, which is also a DVR and IP camera vendor. And then most common vendors such as SonicWall, TP-Link, MikroTik, which most of them are appliances or devices directly connected to networks. So this again makes sense. But I was surprised by the number of IP cameras available on the internet. Also, this machine learning classifier allowed me to spot a very interesting thing. That the fact is that this machine learning classifier was able to group together some devices that, from a first look, like a human won't group together, because we got some device from Hikvision here, another device from Abius. But in fact, this is something, these devices, Abius and Hikvision and so on, are mainly created by Hikvision. This is some hardware and software developed by Hikvision, but sold to other brands in order for them to be able to sell IP cameras and so on. Then by using this classifier, I was able to spot this fact, the fact that Hikvision is mostly used. But I also found many other devices which are quite fun. Some building automation system available on the internet, some PLCs, also WinForm available on the internet, something where, well, it's always the same question, what can possibly go wrong, And also a French swimming pool that I could have interacted with the settings of the swimming pool, and yeah, makes some nasty stuff. And the last part of this presentation, we'll talk about. I am going to talk about weaponizing this stuff. So the first thing is that you can use machine learning to target devices. Instead of just doing some scanner, matching some patterns. And this is what I've done. I did a specific perceptron. I created a perceptron to detect security cameras. And by doing this, I can spot the cameras available on the internet. So let's have a look at it. So this is a specific range with a lot of cameras on it. And as you can see, this little tool uses a specific model I've designed based on the camera category. And then if I take one of these, yeah, maybe like this, one of this device, just wait a minute, this is a zoom effect as well. We can see that, yeah, these devices are mostly cameras. Yeah, that's it. So this is a camera, and this other one is another camera, and so on. So this system, this scanner, is able to spot cameras based on this machine learning. So I have no, I don't need to implement some pattern matching algorithm. This is created based on the collected data I get from my system. So basically, you can then geolocate camera feeds, create a map of camera feeds available, try also default username and passwords. And you can do the same with network attached storage, find default passwords and steal data and so on. So this is very easy to, based from this scanner and this classifier, to know exactly how to target a range of devices. If you're looking for QNAP, for instance, you can use try to exploit the latest vulnerability, which is a pre-authenticated root remote code execution. You can also create a perceptron and train a model to detect QNAP NAS as well. So it's very easy to create a specific search and destroy robot based on the data we collected before. So as a conclusion, machine learning is great. I didn't expect such a result from this little experiment I made, but this unsupervised classifier made my day, because it was very easy to classify all this data, all these devices I detected. Multilayer perceptron also provides an easy way to create targeted tools and to create specific scanners as well, by just observing the various devices out there, and we can derive from these devices some specific scanners without having to implement some pattern matching algorithm or so on. But the fact is that human is still required, because you need to interact with this automatic system to drive it, to guide the system toward the goal you want to achieve. So this is something quite interesting about machine learning. So if you want to give a try to machine learning by using Python and scikit-learn, this is very, very interesting. Also, you can, if you want to reproduce my experiment, you may use other Python libraries such as Request, Whoosh, or SQLite 3. But the most difficult part, I think, is picking the right features and building the correct data sets. Since all the algorithms are already implemented in these libraries, the hardest part is to correctly choose the information you are going to use for this automatic learning. So I won't release any source code because, well, first, my code is quite dirty. It's just an experiment. I didn't plan to release it. And all the key materials provided in this presentation, you get the code snippets, all the parameters I used, and so on. And I learned a lot during this project. So will you if you try to do this experiment by yourself. So thank you for listening, and I hope you enjoyed the talk. And remember, discover new things, experiment, and learn. Thank you. I don't know if you...
Okay, thanks a lot. I have only one question for the moment. All people watching can ask by using the Q on air button. Did you try several models of multi-layer perceptron?
I tried. Sorry, go on.
Did you hear me?
Yeah. Yes. So I tried some different models. The model I'm using in my tool is based on 3 hidden layers. This is a multi-layer perceptron. But in fact, I tried the classical perceptron as well, but it didn't give me very good results. So I tried, just like a lot of people I saw in many tutorials over the internet, I tried many different configurations for perceptrons until one gave me good results. But the multi-layer classifier, multi-layer perceptron classifier, available in scikit-learn with a few hidden layers did the trick. But I think this can be improved as well by using some, maybe some other configurations of different number of layers or of neurons. I don't know. This was just, like I said, an experiment from my side. So I tried to trick the system in a way it gave me pretty good results. Not the best ones, but almost good results.
Okay. If nobody other question, we'll do a very little break, maybe. And the next presentation will be in 2 minutes. Thanks a lot. the pause is over. So we are going to have our last talk. This talk is about IoT. It's an IoT used in the medical purpose in order to detect diabetes. So the last presentation will be done by Axel Apreville, who did other presentation I think the last year, on Travis Goodspeed. Axel is here? Yeah, perfect.
Yeah, and normally Travis is here as well, and he is starting up.
Okay. Can you share your presentation? He has the presentation?
He has the presentation, but of course I can as well, of course.
Oh, I have the presentation. Sorry.
Oh.
Can you see my screen?
Yep.
Can you control my screen?
I am not trying to, no. Yeah, but I'll do it on my own slides, Travis. Keep control on your own computer and I'll keep control on mine.
Okay, that'll work. All right, are we ready to go?
We don't have your slides right now.
Yeah, we don't have your slides. Oh, there, it's coming, I think. Oh, no, maybe not. No, I see only Philip.
Okay.
Maybe you can share them. Okay, perfect.
Yeah.
All right, and you still see them?
Yep, perfect.
Awesome. Okay, howdy y'all. I'm Travis Goodspeed. Today, Axel and I will be talking to you about embedded glucose sensors. These are tiny little sensors that you stick on top of your skin while injecting a little wire underneath the skin that allow you to wirelessly measure your blood glucose from an Android phone or a dedicated reader over the course of 10 days to 2 weeks in order to manage diabetes without having to repeatedly prick your finger. We've been playing with these for about a year now, year and some change. And we've discovered a bunch of fun stuff, such as remote code execution inside of the sensors themselves. We've dumped the firmware of the sensors in order to be able to reverse engineer and patch them. Today, we're going to be talking about how to bypass the restrictions which are artificially added to these medical devices in order to enforce the regulatory lifetime of the device and also the region lock. So we'll be showing you how to take a sensor which has expired and then bring it back from the dead and use it to continue measuring. We'll also show you how to take a sensor from one region, such as France, for example, and move it to another region, such as the United States, where the classic sensors are no longer available for sale. Cool. Axel, do you want to talk a little bit about your background?
Yeah, so I work for Fortinet and I'm a mobile malware researcher there. So I look for malware on mobile phones and on IoT. And also I organize a CTF, which is called Phone and which is dedicated to smart devices. And that's all. Your turn, Travis.
Yeah, so I make electronic wristwatches with radios in them. I collect old cars called Studebakers, which were the very last American car brand to die with dignity. I also made a couple of hardware projects that you might be familiar with, such as the Good Fet and the Good Watch. And I edit a journal along with some other folks called the International Journal of Proof of Concept to Get the Fuck Out. And I'm happy to say that yesterday I turned in the final pages for our third volume, which should be available this year.
Yep. So I'll perhaps switch to my own slides and share my screen. Travis, can you stop sharing your screen, please?
Yes, let's stick with yours for the remainder of the presentation, and then you can set the pace.
Okay, no problem. There we go. So those little devices are called flash glucose monitoring systems. They are used to get the glucose level for people who have diabetes. They do not inject any insulin.
Your screen is not being shared.
My screen is not being shared, sorry. Yep. There we go.
There we go.
And that should be far better. Yeah, you see it that time, sorry. So I was saying that what is important is that those sensors are passive in the sense that they are not injecting any insulin. They just will tell you your current level of glucose. The other thing, but I'm not going to get into the details, but that was what this research document was about, is that it is actually not getting the glucose level from blood vessels, but from the interstitial tissues, basically the upper layers of skin. And well, this has been proved to be relatively accurate to measure one's glucose level. And for science, I tested, as you can see, those sensors on myself, though actually I don't have diabetes at all.
I've not been brave enough to try them on myself.
Well, it doesn't hurt to put it on, but it's very difficult to get it out, get it off. So what we're mostly interested in today is actually the life of those sensors. At first, when you buy them in a pharmacy, they come like that, disassembled in a package where you have one part which has actually the electronics part and an applier, something like that. And here you've got the enzyme sensor, which is in a sterile pack. So you've got to assemble everything, then put it, apply it on your arm, and then you use your smartphone there, and well, you scan the sensor, and it tells you, well, you have, for instance, a warm-up period of 60 minutes. This warm-up period length depends actually on the country where you live. And after those 60 minutes, well, it will tell you, okay, it will decide that the sensor has warmed up enough and is giving normally good results, accurate results, and you can use it. Then you can use it for 14 days. Again, this is a limit that that actually depends on the country. And 14 days later, well, the sensor expires and you've got to go and buy another one. Right. So as you can see, there are quite a couple of limitations there, right? We've got the lifetime of the sensor, 14 days in our case, okay? This is one limitation. Another one is the warm-up time. So we said it was, in our case, 60 minutes, okay? This is also something that we're going to try to hack. And the final limitation is perhaps not obvious to you, but actually the sensors are zoned, just like a DVD kind of. So if you buy one sensor in the US and you want to use it with an application or mobile application of Europe, it is not going to work. It will complain, and reciprocally. So we are going to work around all those limitations in this talk and show you that. Yeah, of course, it is time for at least a disclaimer there. We have tested all of this on the technical side. Of course, we are not medical doctors and we have not done any medical research on this point of view. So, well, we kind of discourage you strongly to play with these. Those, as we can remind, are medical devices, of course. Okay. The important point, though, is that, of course, an attacker could do what we are doing. So it has also some relevance, let's say. So we will directly go to the resurrection demo. So just a few words before I try and do this demo live. Those sensors, they expire after the 14 days, right? The goal of the resurrection demo is to reset them so that once they have expired, they are basically dead. Well, we can bring them back to life and we can reuse them again for as long as we wish, or at least 14 days again. Okay, so now I am going to stop sharing the screen here and share it on my smartphone. So there we go. There, now you see here the screen of my smartphone, and I'm going to switch to another camera so that you can see, if you have a look on Zoom, well, the sensors here that I am playing with. So first of all, I'm going to show you that this sensor has expired. There we go. So I scan it. And it tells you, sorry, it has disappeared a bit too fast, that the sensor has expired, fin du capteur in French, okay? So we have actually implemented an application, GoodV, and which can help us do the hack. So first thing, we're going to read the status of the sensor, and it tells us, you can see it in the middle, stage expired. We reset it, erase, successfully erase tag, everything is good up to now. And now we are going to try and see if it is really back to life again, and we try to use it with the official application. And yeah, it worked, okay? So this sensor is going to be operational in 60 minutes. We brought it back to life that way. So that's it for this demonstration. And now I can stop sharing the screen here and go back to the slides.
For those of you who would like to play along at home, the GoodV application is open source. You can find it on my GitHub. The only thing missing from it is the vendor's backdoor command, or the password for the backdoor command. These are 4 bytes. You can find them in other GitHub packages that are not mine. Patch them in and run this yourself.
Okay, do you see the slides correctly?
Yes.
Okay, it's your go, Travis.
Okay, so the way that this application works is by communicating with the tag using the vendor proprietary commands, which are implemented as a combination of maskROM, which is permanently a part of the chip and identical between all tag versions, and FRAM, which is a unique type of memory that's sort of new to this chip, and commercially it's almost unique to Texas Instruments. FRAM uses very little power, and it is very cheap to write to. So it's like SRAM in that way, in that you can write to it over the NFC channel without requiring the high voltages necessary for flash memory. But at the same time, it's non-volatile when power is removed. So even though this particular device has had the battery taken out of it, the contents of that FRAM remain the same. And this allows for firmware patches to be applied to an unpowered NFC sensor. So what we did was we took the publicly visible portion of the memory, which is the FRAM. We read that out, and then we reverse engineered it well enough to understand its protocol. We combined that with sniffed transactions from the Android app, and we're able to identify the password and the usage convention for a command that dumped out all of memory. This command is a raw read. You give it an address in the 16-bit address space of the microcontroller, and it dumps out all of the firmware. With that, we were able to load the firmware into Ghidra and decompile it, and then understand everything that happens inside of the sensor. This is not quite the same as understanding everything that's used in the device, because half of the logic is held within the sensor, while the other half of the logic is inside of the Android app. So as of about 4 or 5 months ago, we were able to patch the code running inside of the sensor. We were able to patch the data. We were able to change its state. We were able to remove the write protections on sensitive regions. But we didn't quite understand the, of all things, the CRC checksum that verified that this data was accurate. And so without changing that CRC checksum correctly, when the tag went back to the app would see the data, see that the checksum was wrong, and then know that the sensor was invalid and tampered and would reject it. The other thing to see here is on the top left under the program tree, you'll see that there's a ROM section, an SRAM section, and an FRAM section. A big piece of how this code works is that the FRAM is patching the ROM while not being a part of it. So there's a large table of function pointers inside of SRAM that are used to facilitate this linking, which are initialized at startup by the ROM. This is the same patching procedure that was used by the original Palm Pilot and Apple Newton. So, if you'd like to read more about the firmware, take a look at our Paco GTFO article. But for now, we're going to talk about the E0 command. And the E0 command is disabled in that the FRAM has a list of new commands which are hooked by the patches against the mask ROM. And the list is ended early in that the table has a start marker and an end marker. And the end marker comes early as part of how the chip is locked as it leaves the factory. So we could see that this code existed. We could see that it called back into mask ROM, and having a dump of the mask ROM, we could see the function that it called, which you see here on the right in the screenshot at 5256 in mask ROM. And we could see that it resets the sensor. We could disassemble it. And it allowed us to understand some of these fields that were held. Like there's a global variable inside of the code that stores the stage of life. And it's 0 when it's inactive. It's 1 when you're activating it. 3 is it's operational. 5 is it expires. 6 if it dies an early death, such as if there's a power failure, or if the values that it's reading are so nonsensical that it has to be damaged. And each of these sections is separately protected by a CRC. We could even see the code calling into the CRC peripheral to compute this checksum. And at one point, we were almost desperate enough to write a program which would run inside of a modified sensor just to calculate CRCs for us by having the phone send all of the data into the chip and then read back the result. So to reset a sensor, as far as the firmware is concerned, you just need to set the stage of life byte, and you need to set the activity switch byte so that it believes that it's ready to be used, but hasn't been used yet. And then you also need to format the record section so that it doesn't believe that it's gone through any amount of active lifetime. And all of these are in FRAM. Writing to them is just as easy as writing to RAM. But you need that CRC to be correct.
Yep.
This one's yours.
Yeah, I'll stop from here. So I'll switch to another camera, and there we go. Yep. Share screen. And there we go. So yeah, computing a CRC shouldn't be difficult, right? It's just a checksum with 2 bytes in this particular case. But well, which one is it? We hadn't realized there were so many, okay? So many different CRCs existing, slight little variants and things like that. So we tried them all, and none matched the sensor. So to be honest, at this part, well, we were kind of, yes, what Travis said, a little bit desperate there. And several months passed before we understood the silly solution, of course. We bumped into a forum of Texas Instruments chips, and somebody was asking exactly the same question. He was saying, oh, well, you know, I'm trying to do this checksum there, and no way, I'm not getting the correct result. And the answer was, well, the CRC module is shifting the bits in the opposite direction of CRC16 CCITT. Okay, we hadn't thought about that, the opposite direction. We had tried to fill all the memory input with zeros. We had tried to fill it with FF. We had tried plenty of different solutions, but not that. And of course, we weren't able to recompute the CRC correctly. With that, once you know it's just, well, the opposite direction, well, you just implement it, and we were able at that stage to recompute any CRC and therefore to fool the sensor to believe that its memory was absolutely correct. So, well, you saw in the video that we were able to do resurrection. Well, if we have the power to reset a sensor, we obviously have the opposite power, which is to kill it, right? It's just as simple. You probably have understood how we will do it. We will just shift the stage of life byte to the expired value, which is 5, or 6, which is error. That's one way to do it. The other way to do it is just to ruin one of the CRCs or one single byte in the sensor so that the CRCs no longer match. In that case, the application, when it reads the sensor, it will notice that the CRCs are not matching, and it complains and says, your sensor is corrupt. Go and get another one. So we hacked the lifetime of the sensors, those 14 days. We also said that we would hack the warm-up time, okay? Those 60 minutes at the beginning before the sensor is actually usable. So for this one, we are going to show you this time a video, but the setup is the following. We are going to use actually Frida. You probably have heard of that, which is going to help us install a hook on the application, the official application, which is used to communicate with the sensor by NFC. We are going to hook the exact functions which actually retrieve the limits for the warm-up time and also for the wear time and other stuff, right? And instead of reading here 60 minutes for the warm-up time, we're going to modify this and say, I don't know, I want a warm-up of 5 minutes, I want a warm-up of 2 minutes, and this is how it's going to work. So I've got to switch to the video.
And it's worth noting that for this limit, we're only patching the phone. The sensor itself has no internal concept of the limitations on a warm-up time. And the sensor itself does not enforce this. It freely provides readings even during the time when the application won't show you the results.
So there it goes. I'm just showing you at the beginning that, well, this sensor is has expired, just to show the full thing. And then second step, I'm going to reset it. So I take the same sensor, reset it. It's not readable, but now it is. You can see it full screen. It tells you I have erased it successfully. And then the next step is to, well, to patch, to do the hook. And so I am going to specify, you might have seen, a warm-up time of 2 minutes. I am also modifying actually the wear time limit to 4,800 days. And also we'll see that a little bit later. We can modify actually the glucose value that's the application is going to see. So here, well, we are running the hook using Frida. Here we've got the communication. And then it tells us, okay, notice warm-up time, 2 minutes only. So here I modified the hook so that the glucose level is going to be set to a very high value, 500, for instance. And we're going to scan again and see what happens. Yep. So the phone sees 500 for the current glucose level. And we can do again the same thing and put this time a very low value. Well, it will work exactly the same thing, the same way. We just recompile again our hook and rescan. And this time the application will see a very low value and will complain. As a matter of fact, it's even more critical on a medical point of view. So this time it won't be orange, but it will be dark red for very low value here. So this is the setup. Okay. So this is the video, all fine? Oops. Okay, I'm always on the wrong video as it seems. Let me have a look. No, I should be on the right video over here. Okay, do you see my screen correctly? When I share it, I'm gonna share it again.
No, we don't see it.
Okay, fine.
Okay, now yeah.
Good, thank you. So those were the backup slides, just in case something went wrong, but you see 500, for instance, glucose value, the hacked warm-up time here. And here you might have noticed that the wear limit has been hacked with a very long wear time limit. So we hacked that one as well. And now the last thing that we need to hack and talk about is the geographical location. Travis.
So these sensors are sold in many different regions, and then the regions sometimes change over time. For example, Region 1 is the European Union, including the United Kingdom. Region 2 is for American 10-day sensors. Region 8 is for Israel. And there are presumably others in this list. The reason why they're locked to each region is twofold. First, medical supplies are sometimes sold on a secondhand market between regions with different prices. For example, purchasing these sensors without a prescription in Israel costs about as much as purchasing them with a prescription in the United States. And if they are sold secondhand, this sort of keeps them within a single market, because the official readers for one market will refuse to operate with sensors from another. This also, whether by design or by accident, works as a way to enforce purchasing new equipment as the devices are modified. So Region 2, for the American 10-day sensors, these are no longer available. And if you go into an American pharmacy and you have a prescription for these things, you will only get the new 14-day sensors, which do not work with the 10-day reader. If you want to continue using your old equipment, you need to import foreign sensors and then change the region byte, which we can do, and then modify the CRC in order to make the reader believe that it has always been a part of the new region. If you do this before activation and continue along, then everything works fine.
Yep, have you, okay. So the last thing we wanted to say about this is that, well, it's extremely cool and nice to, well, to hack a sensor. It was really interesting work. But to be honest, although those hacks are not extremely difficult, they still are a little bit difficult, let's say. It is really far easier to hack a smartphone and just, for instance, code a 5-minute application, mobile application that will do a denial of service on the smartphone. And so in that case, as the sensor isn't that bad, that badly designed and implemented, the weakest link is not the sensor, but the smartphone. Okay. So that's just something we wanted to point out here, is that, well, you've got to secure your smartphones, because if you're using them for medical use, well, then it's going to be so simple, just unfortunately, to get your phone infected with a ransomware or with a fake diabetes application. And there are really quite lots of them. It's not just one or two. So really take care of your phone if that is the case. Travis, when we'll wrap up.
If you're interested in more on this subject, we have a technical report that will be coming out soon, or is this already available?
Sorry, it is out.
Yet?
It is already out on the link, and I believe it will probably be up somewhere also, maybe on the website or something of Past Assault.
The GoodV Android application is available in my GitHub account. In order to perform patching, the only thing that is missing is the vendor's 4-byte backdoor password. You can find this elsewhere or sniff it from the vendor's application yourself. We have a Python script which dumps the FRAM out of a sensor using an NFC reader and then decodes it in order to show you the values from Python. We have a Paco GTFO article in issue 20 on how to work with both this chip, which is the RF430 TAL152, and also the publicly available chip that matches it, called the RF430 FRL152. And then we have a presentation from Blackout on how we dumped and reverse engineered the firmware. All of these are publicly available.
Yep. And thank you very much for listening.
We have a question from the chat. Did we try CRC Revenge, and did this work?
So the answer is probably no, because I do not know crcrevenge.net. Let me have a look immediately.
So, this is a publicly available tool that reverse engineers CRC values, given a set of data and an example checksum.
Okay. So no, I didn't try that, but I did try online computations of CRC. So I would just feed in the memory blocks and see the different output for all the types of CRCs, or nearly all the types of CRCs that that exist, and that's how we found out that it wasn't matching anything in there. And then I did a script, my own script, to modify the memory values and put some zeros instead in the blocks, or some FF in the blocks, or things like that.
We have another question from the chat. I have a question regarding the wearing time. As you said, the modified duration value on the Android app, you modified the duration value on the Android app with Frida, but does it affect the sensor too, or should we wait 14 days and resurrect it again?
I'm reading it again. As you modify the duration. So the answer to that one is that it's so the duration value, so the 4,800 days that we said that we hooked in with Frida, they do affect the sensor life, because as far as I know, there is no such limitation on the sensor itself. So which means that we could have been using that sensor for those 4,800 days, provided that the battery didn't wear off before that time, of course. So yes, it absolutely affects the, well, the sensor is usable for that 4,000 days, sorry.
And this is because the sensor has no internal real-time clock, and its only accurate concept of the outside time comes from the app. It has an internal estimate, but that can drift. We have another question. Is it possible to use JTAG interface on TAL chips?
No, that's for you, this one.
Yeah, this is infuriating. So the way that the public chip works, the documented chip, the FRL, is that there is JTAG, and JTAG is not quite compatible with the public tools, but you can patch those tools to add compatibility. And the difference is that there's an unlock value or a key, not really a password, but something like it, that is written in by JTAG in order to expose the interface. This value can be found for the public chip. For the private chip, we tried that same value. We tried guessing them. We tried fuzzing them. We were able to set everything up to where the JTAG should be unlocked. We had the wiring confirmed correctly, and we never managed to get a connection. We don't quite know whether it's because we don't have the correct 32-bit unlock value, or if there's some other type of lock in the custom proprietary chips like the TAL. Some more questions from the chat. What is the maximum time the sensor can be used without risk? The sensor is very expensive in the United Arab Emirates.
So I can perhaps a little bit answer there. I know that the vendor has certified it for 14 days. I saw some medical articles there where it had been certified in the US for 14 days, meaning that they had measured that the sensor gave accurate results until those 14 days. And then that it was decreasing, but I do not have the details of how fast it is decreasing. And I do not have either the details on the medical part. Is it going to, I don't know, to affect your skin, to be too long on your skin above those 14 days or things like that? From a technical point of view, there is absolutely no issue to be using them more than those 14 days, okay? The issue is only medical here. Travis, if you have anything else to add to that question.
No, that's about right. The sensor can be made to record further, but we know nothing about how the accuracy drifts. Presumably, the 2-week measurement is rather conservative in order to ensure that the results are always valid. At some point, the results will begin to drift too far, and it will begin saying that your glucose is different from the real value.
Yeah, we have another question, I believe, for you, perhaps, Travis. Another from the chat is there a way to reset the TAL 152 to its factory settings, getting rid of all Abbott code? So I believe this would be like moving it to TAL to nearly FRL 152, perhaps?
So you can do this by removing the TAL chip and soldering an FRL chip in its place. But you cannot do this through software, even if you had a JTAG connection, because the TAL chip contains a different mask ROM from the FRL chip. And you can see by reading the code that they forked off rather early. They have many of the same functions, but with different parameters and calling conventions. So so it's not possible to replace the mask ROM of the chip and remove the Abbott code from there. But it is possible to change the FRAM code. So if you wanted to put a small game into it, or if you wanted to hide a message in there, or run new sensor code of your own to reuse the existing chip, you can freely do that. There will just be some of the original code remaining. I think that's the last for the questions.
Yep, looks like. Well, thank you very much.
Thank you. For this presentation, I'll give power to Christophe in order to close the conference. Thanks a lot.
Thank you.
Yes, thank you very much. It was the last talk of this third edition, of this first edition in a virtual mode for us. It was quite, it runs quite smoothly. So I hope you are quite okay with the way it ran. As a register attendees, you are going to receive a form to get your feedback. Please fill it and send it to us. It helps us a lot to tune the things that are quite a success and the things that have to be improved. So I am going to share some short number of slides just to give a last exposure to all of our sponsors. Thanks to them to support us this year and next year, as I previously said in the introduction talk. What we really want to be able to do next year is to meet you again in real life. It will be the way to have very important things like stickers, like chocolatine or pain au chocolat during the pause. Also to arbitrate some very important question in order to choose what is the better between Chamonix and Figaro. All of these are quite important question in France, but what it really matters is to meet you again in real life, to be able to exchange, be able to build more software, exchange on ideas, around free software and security in real life. It's according to us what it really matters. So thank you very much to have been there between 50 and 100 people online all along this free afternoon. We are really pleased to have you that form, and we really wish you to see you next year in real life. Thank you very much.
Au revoir.